All right, so everybody's get out your practice test. We have a test on Thursday.
Cool.
So we have an opportunity to practice today and tomorrow.
515556.
Yep, 15556. That is exactly right. So I am finding mine here. And we are on practice test number 1. This is the one I stapled wrong. Sorry about that. And we are ready to start in the box over there in front of the bookcase. We are ready to start practice test number 1, problem number 3. The directions say how many triangles are possible, and you are to show your work. Now, why did Miss Ford say show your work? Because the answer to every one of these problems in this section is either 0, 1, or 2. So you could guess. You're not getting points for guessing. You need to show your work. Now, the good news is the work is the same over and over and over again. So every problem is going to have exactly the same work. So let me show you, let's refresh our memories, how we do these problems. All right, so we've got this triangle, and we know that's 61 and 12 and 14. Now, when you look at this problem, the first thing you notice should be, oh, look what we have. So we're going to set up the law of sines. So we'll start with sine 61 over 14 equals sine C over 12. So now we will multiply, cross multiply, and we will type into our calculators 12 sine 61 divided by 14. Now, when we do this, we get a decimal, right? How do we get the angle? We really want to know that angle. We have the second sign, right? So I'm going to second sign that decimal, and I got, tell me what you got, those of you with calculators, 48.56. Now, if there is a second answer, if there is another angle C, how big would it have to be? If there is a second answer, how do I always find it? Always the same way. What do? Subtract this from 180. The second answer is always 180 minus the first answer. So that would be 131.44. Okay, so let me say that again. You're going to type in your law of sines. You're going to second sign this decimal to get the actual angle. Okay? Then you're going to subtract from 180 and see if you could have this triangle. Would this triangle be okay? No, why not? The angles are too much. They're more than 180. So if there's a second answer, it's 131, but it can't be 131. So therefore, how many triangles are possible? One, just that one. That's the only one that makes sense.
What'd you do with the 48.56?
Subtract it from 180 to get the possible second answer. So A is 1. There is one triangle possible. All right, so now I'm moving on to B. is this set up exactly the same? Yeah. So we're going to do exactly the same thing. Curvin, you wait, honey? All right. So we're going to say sine 52 over 6 equals sine C over 10. Right? So sine C is going to be 10 sine 52 over 6. Now we're going to type that in. We're going to get a decimal, just like we got before. And then we're going to second sign that. What happened?
Got an error.
You had an error message. And when that happens, you know how many possible triangles? 0, none. None. No possible triangles. You got an error message. You couldn't even get the first angle. You got an error message. All right, so now we're going to do this one. Okay, so how do we start? Yep, sine, just like we've been starting, sine 68 over 19, sine C over 20. So we're going to figure out what angle C is. So we do our cross multiplying. And we get a decimal, just like before. So what do we do with the decimal? Second sign it. Robbie, you should be practicing, honey.
Yeah,
You're going to be away from this for a while. Okay, you already did it? So I got 77.4. Did you? Now, if there is a second answer, that second answer would be 180 minus the first one. So it would be 102.6. Now, would that be possible for that? The given angle was 68. Would it be possible for the second angle C to be 102.6? Does that work? Yes. So how many triangles are possible? 2. This one and this one are both okay. All right, part 4. This little section is all about area. And as luck would have it, I put the hardest one first. This is the hardest one. So if you don't mind, let's just wait a second on that and let's do the 2 easy ones first. And then we'll come back and get that one. That's the hardest one. You'll see why in a minute. Maybe you already know. Here's the deal about area, kids. This is problem B. Here's the deal about area. There are 2 things I would really like to have. If my job is to find the area, I would love to have all 3 sides. So I could do Hero's formula. Remember that, the radical one? Or I would love to have 2 sides and the included angle. Okay, if you don't know this yet, you need to get this down. When you do area, there are 2 things you want. You either want all 3 sides, or you want 2 sides and the angle in between them. If you have 2 sides and the angle in between them, the area is just 1/2 side, sine of included angle. 1/2 side, sine. So when I do area, I love having two sides and the angle in between them. Because then the area will always be 1/2 side, side, sine. And I just type it in. That's going to be the answer to the question. So it's 86.59. That's your area. Yep.
So for the one before that, could you find like?
That's what we're going to have to do. You are right.
And then do that.
Yep. That's exactly what we're going to do. We're going to come back to that in a minute. But you're exactly right. When I do area, kids, I either want all three sides or I want two sides and the included angle. Like Robbie pointed out in problem A, I don't have either one of those things. So I gotta find one of them. I gotta get something. Okay? So since we're talking about it, let's come back and do problem A. Wouldn't it be awesome if I had side Q, for example? If I had side Q, I would have side, side, and included angle. So maybe before I start, I need to find side Q. But I can't find side Q until I find angle R. But that's easy because 81 and 47, and so what is that? 50, is that 52? So now I'm going to find side Q. Because if I want area, I need two sides and the angle between them. So sine 47 over Q equals sine 52 over 6. We're going to do this problem just like we did this one, but it's got that first step first. I got to find side Q in order to do it. So I'll cross multiply. And I'll divide. So Q ends up equaling 6 sine 47 over sine 52. Is that right? You okay with that? All right, so what is side Q? About 5.57. What's the matter?
Why not just when you put side 52 sides 52? Like we divided it by side 52.
Okay, first of all, it's an angle, so you're never going to divide by a plane angle. It's always going to be the sine of the angle, but it has to do with when I set it up. It was sine 47 over Q equals sine 52 over 6. So when I cross multiplied, I got 6 sine 47 and Q sine 52. I ended up dividing by sine 52 so that I could get my Q by itself. It's just the variable, oh, I don't have any more, but the variable is in a different spot than it was in the other equation. Idea is the same, but it's set up differently. All right, so we got Q. Now, how do we find the area? That was our job, area.
1/2 side, side.
1/2 6 times 5.57 times sine what?
81.
It's got to be 81, kids, because you have to use the angle between the sides that you're using. Two-step problem. Tough one. All right, one more area. That is C. Uh-oh. Bailey, did I make a mistake? Okay. What's going on here? I have all three sides, which is good. Good. I like having all three sides. If I have all three sides, then I can find my area using Hero's formula. Remember, Hero's formula is the big radical that has 4 numbers underneath it. Who remembers what those 4 numbers are? Deshani?
The first one's the semi-perimeter.
Okay, stop right there. The first one is the semi-perimeter. What do we mean by semi-perimeter?
Perimeter.
Half the perimeter. So your perimeter is 28. So half of that would be 14. So the first number that goes under the radical is half the perimeter, 14. Now, do not put 8, 9, and 11. That's not how it works. How do we find those numbers under there? It's 14 minus each of those. So 14 minus 8, 14 minus 11, 14 minus 9. Under the radical goes the semi-perimeter, and then the semi-perimeter minus each side. Then we just multiply them all together and take the square root. And I got 35, basically 35.5. Only one more page. We'll be done with this practice test, short test. Nope, shouldn't be that hard at all. Here we go. These are the word problems though. Let's see if we can figure it out. Draw a picture, write an equation, solve, round to the nearest hundredth. All right, you've seen those directions before in your notes. So here we go. Find the area of a regular octagon inscribed in a circle with a radius of 12. Okay, oh my gosh. Okay, what do we do first? Let's draw a circle. What does octagon mean? All right, so let's make 8 marks around this circle. And let's connect those points. And there's my octagon.
The radius is 12.
Okay, so everybody catching up here? So we draw a circle. Since it's an octagon, we're gonna put 8 marks around the circle. Try to spread them out evenly. We're gonna connect those marks. This is our octagon inscribed in a circle. Now, the circle has a radius of 12. So you can put your spokes in. Do you understand what I mean when I say spokes? And how long is each of those spokes? 12. They're all 12s. All these triangles are the same size. Would you agree with me? Now, I need to find the area of this triangle right here. Because if I know that area, then I know all those areas, and I can find the total. So, what did Mrs. Ford tell you? If you want an area, what do you want to have? You either want to have all 3 sides, or you want to have 2 sides and the angle in between them. All right, so let's look at this. It would be great if I could find that angle right there. Can I? Yes. That angle is going to be 360 divided by 8. So that angle is 45. Now I have two sides and the angle in between them. So the area of that triangle is this is a triangle. The area of the triangle is 1/2 side times sine of included angle. 1/2 side sine. We use it every chance we can. 1/2 side sine. Now, I can type that in, obviously. And I get 50.9. But be careful. What is that? That's the area of the triangle. I need to take that answer and say times 8 to get the area of the whole pentagon, octagon. So the octagon area is 407.29, and that would be square inches. Now, does anybody need to ask a question about that? What there confused you, or do you think you couldn't do on your own? Eric? 360 degrees all the way around, and there's 8 of them. So it's 360 divided by 8 if I divide it right. Okay, all right, number 2. Find the length of the shorter diagonal of a rhombus. Oh my. Who remembers what a rhombus is? One of my favorite words in English language, rhombus. What is a rhombus? It's a slanted square. That's exactly right. So a rhombus has all sides congruent. So a rhombus looks like this. This is your rhombus. And all the sides are 16. And the smaller angle is 34. Now, kids, you need to eyeball the picture and recognize you got these 2 angles and this one's smaller. That's the 34. Then you need to eyeball it and agree that this is the shortest diagonal. That's going to be shorter than that one. Just eyeball it. You can tell that. And we want to find how long that is. Find the length of the shorter diagonal. Yes, it's going to be a law of cosines problem. Why? Okay, stop. If you're finding a side, that is a length, or an angle, it's either going to be sines or cosines. Jonathan?
Yeah.
You know what I'm going to say to you, right?
No.
So what's the appropriate thing to be doing right now? Yes. And you were not being appropriate. And you know that drives me freaking crazy, right? Okay. All right, so when we're finding a side or an angle, we're going to use the law of sines or the law of cosines. So you need to look at your situation. You're finding a side. Here's your triangle. You're finding a side. Do you have the right information for the law of sines? No. So we're going to have to do cosines. So we'll say x squared equals. Now, what's the rest of the law? Who remembers? 16 squared plus 16 squared minus 2 times 16 times 16 times cosine 34. So it's side squared plus other side squared minus 2 times side times the cosine of the angle. All right, so we can type all that in. And can you guess what the biggest mistake that's made? Not square rooting it, that's right. Kids forget all the time that what you're typing in is actually x squared. So you need to remember to square root that. And I got 9.36.
I was way
So
off.
that's after you square root.
You're right.
After you square root it, you get 9.36. Is that right? Number 3. All right, take our rhombus and find its area. Now, this is a different problem. Area, what are the two things I look for? Either two sides and the included angle. Stop. Two sides and the included angle. Do I have it? So the area of the triangle is 1/2 side times sine of included angle. Did you get 71? Okay, now be careful, because here's a place you make mistakes too. What is the 71? It's the area of the triangle here, right? If we want the whole rhombus, we have to do what? Times it by 2. So the area of the rhombus is 143.15 square inches? Or centimeters, I'm sorry. It's not inches, it's centimeters. You have to go. Yeah, giving blood is a huge gift.
Where, at one point we had 71 or something.
71 was the area of the triangle. Doubled it
Yeah.
to get the area of the whole rhombus. Okay, one more problem and this practice test is done and we'll start the next one. Find the area of a regular hexagon inscribed in a circle with a radius of 14. Now wait a minute. Is this kind of familiar to another problem we've already done? Yes, you know you're going to have to do this on testing. What's our strategy? We'll draw a circle. This time though, it's a hexagon. So how many marks will I put around my circle? 6. Try to space them as evenly as you can. Obviously it's not going to be perfect. Mine's not certainly not perfect. But get them spaced out as best you can. And then connect those dots. So you put 6 dots around your circle and now you're going to connect them. So there's your hexagon. All right, John, what's the next step after I got my hexagon done? Well, I gotta do something first before I can do the formula. I'm gonna draw the triangle. So here's my center, and it says the radius is 14. So I'm gonna put all these spokes in here, John, and create all of these triangles, so then I can use my formula. Right? Now I'm doing area. So what are the two things? Either all 3 sides or 2 sides and the angle in between them. Do I stand a chance of finding the angle in between these 2 sides? Yeah. How do I find that? 360 divided by 6. Why 6 this time? Hexagon, right? So 360 divided by 6 would be 60. So the area of the triangle, 1/2 14 times 14 times sine 60. So 1/2 times 14 times 14 times sine 60. Okay. And then remember to do what? That's the area of the triangle. So we need to take it this time times 6. Hexagon, 6 of them. So the answer is 509.22 square inches. What do you think? Is that all right? That's cake. Well, I hope so. All right, we got time left. We're going to go straight to practice test 3. We're going to number 3. Yeah, 2, we're not doing 2 right now. We're going straight to 3. So everybody find practice test 3. I'm sorry about the way I stapled it. It's not good. All the newfangled technology, just, it's too much for me. All right, I think we know the killer problems are going to be the first couple, right? That's the hard stuff. Let's see if we can figure it out. So here I am on practice test 3. I am looking at problem number 1A, and my job is to simplify it. Now, I really want you to look at the numerator. What do you notice about the numerator? We are on practice test 3, problem 1A. Ah, very good, Emily. It's the difference of squares. This is a square and that's a square. So when we have the difference of squares, we can factor it. How does the difference of squares factor? 3 minus sine x, 3 plus sine x. Remember when you have something like x squared minus 4, it's x minus 2, x plus 2. This is exactly the same thing, only it's 3 and sine. So 3 minus sine, 3 plus sine. Now what do you notice? You can cancel. So the answer is 3 minus sine. Your job was to simplify. That is, break it down as much as you can. That's what you did. That's it. So what if this had been a 16? How would that have factored? 4 minus sine, 4 plus sine? And then nothing would cancel then, but I just want you to recognize you can always factor your difference of squares. All right. B, this one looks a little hard. All right, what do we do with these problems that look like this? We had a quiz over this. What do? We change everything into sines and cosines. So if it's a cosine or a sine, we leave it. So cosine stays. Now, what about cotangent? Cosine over sine. Right? Plus sine. All right, let's multiply these two together. Okay, now that's like cosine over 1 times cosine over sine. Nothing cancels. I'm going to be left with cosine squared over sine. Cosine times cosine, 1 times sine. I'm multiplying these two together. Top times top, bottom times bottom. And I'm adding that to sine over 1. How do I add fractions together? I need a common denominator. So this one doesn't have a sign in the bottom, so I'm going to give it 1. But you can't just put it in the bottom without putting it in the top. So I put a sign in the bottom and a sign on the top. Now, do they both have the same denominator? Yeah. One denominator. What's on top? Cosine squared. Oh my gosh. What's cosine squared plus sine squared? 1. So this is really just 1 over sine. Which you can leave like that, but if you'd rather write it as cosecant, that's fine too. Alright, so now we'll do one more problem here. We're doing number 2A. Problem 2A says solve the triangle. Now, I kind of gave you a hint by putting all those blanks down there. What does solve the triangle mean? Find what you don't know. So what I don't know would be angle A, side B, and side C. That's what I don't know. So first I can find angle A real easily, and that would be what? 80?
80, yeah.
So everybody gets those points. That's a no-brainer. Right?
Yeah.
Now what? Okay, this is where we have to decide, am I going to do the law of sines or the law of cosines? Can I do the law of sines?
Yeah.
Uh-huh. So sine 80 over 10 equals sine what? Pick one.
Sine 53 over C.
53 over C will be fine. Sine 53 over C. Could we have also done sine 47 over B? Yep, we're going to have to do them both. The order doesn't matter. So I'm going to cross multiply, and remember, Trey, the angle always sticks with the sine, so it's always a sine of the angle. You can't separate them, so sine 80 is what I'm dividing by. I got 8.11. And that was side C. Now we got to do it again. That's right. In fact, we're going to do exactly the same thing. Still going to use sine 80 over 10. But now we'll say sine 47 over B. So we're going to do exactly the same thing. B sine 80 equals 10 sine 47. And then B will equal 10 sine 47 divided by sine 80. I got 7.43. Anybody match that? And that triangle is solved. So tomorrow we will pick up right there and finish this practice test. Thank you.